Welcome to Hidden Layers, where we explore the people and technology behind artificial intelligence. I'm your host, Ron Green. We're back with our monthly Decoded episode, where we cover the most important news and announcements in artificial intelligence. There's news from Apple, Black Forest Labs, Anthropic, Google, and more. To help me cover it all, I'm joined by two of my amazing Kung Fu AI colleagues as always, my co-founder and distinguished engineer, Dr. Zizi Tsai, and VP of Engineering, Michael Wharton. Zizi, Michael, welcome back.
Thanks for having us.
Thanks.
Okay, I want to kick off with the Illusion of Thinking paper that came out of the Apple AI research group. This came out about a month ago. It essentially used the problem, the Tower of Hanoi problem, which is like an old puzzle, and I'll give you a description of that in a second, to try to measure the reasoning ability of these models, and it came back with a pretty negative result. For whatever reason, when I heard about the paper, I was pretty skeptical right off the bat. Like it just didn't seem like it was accurate, and there's been some pretty interesting critiques of it. So let me set things up. So the paper is called The Illusion of Thinking, Understanding the Strengths and Limitations of Reasoning Models via the Lens of Problem Complexity. So the Tower of Hanoi problem, briefly, is a problem where you have little disks and you have three basically pegs, and you have to, each disk is smaller than the one below it, and you have to move the disks from one peg to the other, but you can only move one disk at a time, and you can never have a bigger disk on top of a smaller disk. Okay, so the challenge here is that as you add disks, the problem becomes pretty complicated. It grows exponentially the number of steps you need to take. There are, very simple recursive, computer science algorithms to solve this problem that'll work on any size, any number of disks. But what the researchers did here was they said, you cannot use an algorithm. You have to literally describe the steps one by one to see how it could scale from a reasoning perspective. They found that once in the number of disks got beyond a certain size, the model's reasoning abilities essentially completely collapsed, and it got 0% of the puzzles correct. Seems a little odd, right? So I read the paper, went and did a bunch of research on sort of public criticism, and I found some interesting things I want to share. So the first one was, turns out that because it's got this exponential growth, once you get to 15 disks, and the normal like human puzzle will have 3 or 4 disks if you see them in the real world. But once you get to 15 disks, there are 32,767 moves. But once you're at 20 disk, it's over 1 million moves. So you'd have to list out 1 million moves, where they were asking it to solve those level of that level of disk complexity. Turns out, even with the 64,000 token allowance they gave it, there wasn't enough context window. I mean, literally, it couldn't spit out the right answer.
Yeah.
Like literally. And so the collapse was guaranteed. There wasn't enough context window, which is just kind of crazy. Anything above 14 was guaranteed to have collapse. Fundamental problem right there. Second one was the way they did the scoring format. If the model output like a concise algorithm and said, oh, it's a recursive solution, you move n minus 1 disk here, and you basically solve it this way, they would mark that entire solution wrong. They would say, no, you have to lift the steps out. Interestingly, I think you can say that the evaluation was literally punishing abstract reasoning, the very thing they're trying to measure, right? They're trying to measure reasoning, and they're sort of punishing this higher level abstraction.
Well, why the narrow focus on the Tower of Hanoi problem also? Because I feel like these reasoning benchmarks are meant to be diversified tests of reasoning. And
that's a great question. I think that right there alone maybe set off my my suspicion initially, because I was like, that is just such a very narrow task and it's once you understand the trick and it's recursive, I mean, it's actually not that complex. So I don't really know. I know there were some other things they were trying, but that was the main focus. And I think they thought it was something that they could scale the complexity on. So you could start small, it succeeds, and then you would see, could it continue to reason as the complexity increased? And then the last thing, there were many of these, but many of the critiques. But the last one I'll say was they used a temperature of 1 for sampling. That means that they had maximum variance, right? And they essentially, quote, entangled luck with skill. Right. And a better approach would have been use either deterministic decoding or a large sampling number to kind of average things out. Okay. So I won't go through the rest of the critiques, but this is the best part about this. And this is probably the reason I'm mentioning this here today is everything I just gave you, all of those critiques and more were generated by OpenAI's O3 model when given the paper. So there's I just think this is amazing. They're literally the paper that purports to find reasoning shortcomings. Oh, wow. There were all these reasoning shortcomings found within the paper by a reasoning model. So I mean, to me, it's just like amazingly hilarious.
I love it.
I love it.
That's amazing.
Yeah, I really do too. All right, Mike, I'm going to throw to you.
Cool. Well, I was going to talk about this paper called Fast and Simplex. It's from Meta. And I think they just poached some people from Apple, all over the place.
Yeah,
so
that's a whole
makes sense there'd be a brain drain.
The whole super intelligence group that they're standing up, they're poaching people.
Yeah, the Alexander Wang stuff. Yeah. But anyway, yeah. So this is from the Meta Lab, and the whole idea here is to focus on the scaling law problem. And to just cut to the chase, basically what they did was they took an old, I would say, underexplored technique that came out in 2019. That's sort of a new flavor on transformers, and tested how that scaled relative to our modern dot product attention. And it seems like it actually changes the exponent on the token budget part of the scaling law, and it makes the training process more token efficient. Okay, so it changes the slope of the curve, that log loss curve. Yeah. Okay. Yeah.
So you need less data to achieve the same accuracy.
That's exactly right. And yeah, for folks listening, I know we're all probably pretty familiar with power laws, but basically the idea is that to achieve a given training loss, it's a function of both the model size, the number of parameters, and the amount of tokens that you train the model on. Yeah. And there's actually a compute optimal combination of those two that depends on, whatever your starting point is. That was in the that Chinchilla paper from a couple years ago.
Yeah, legendary.
Very, very cool paper. But so there's this growing body of research that shows that most of the changes that people tweak with modern architectures, training techniques, optimizer variants, and things like that, they only really shift the curve. So unless you can actually fundamentally change the shape, then the payoff of increasing scale is pretty much the same. Okay. Even if you come up with some clever optimizer or something. But what they did was, traditional dot product attention, you have queries, keys, combine those, you get your attention matrix, and you combine that with a value matrix. Well, instead of getting an attention matrix, they basically just add another projected set of keys. They call it K prime, and they combine it to create an attention tensor. So it's 3 dimensions now. Mm. And what that allows you to do is to capture a lot more complexity. So, with pairwise comparisons you get from attention, it's vectors compared to vectors. Mm. Now in this formulation, you're comparing vectors with other pairwise comparisons of vectors. Okay. If that makes sense.
Yes, absolutely.
It's all good so far?
All good so far.
Okay, cool. So that's kind of scary when it comes to scaling.
I was going to say, that we're going in the wrong direction there already. Okay.
Yeah, like state space models, they're trying to move us in this frontier to stuff that's more simple. Right. But these models are going more cubic. Yeah. So they have to, of course, invent all these techniques to make it compute efficient, like sliding windows and all sorts of stuff. But the cool thing is, I would say it's still pretty underexplored, but they looked at 1 billion, 2 billion, and 3.5 billion active parameter mixture of expert models. And if they empirically fit this scaling curve to those and they use this modified technique, they do show that they can improve the scaling exponent.
And is the amount of compute that is being done, is it because you go from quadratic to cubic with this higher dimensional tensor, but do you remove, like, instead of having key, query, value matrices, do you not do you not need all of those now? So you save compute, or is it just no? There's more compute, but you get more bang for your buck for that compute.
There's still, I actually would say it's kind of an unfair comparison because they compared the compute requirement of their modified windowed technique to traditional dot product attention, which I would say is not fair because you can still do the same windowing with traditional dot product attention. But I guess the compute budget with it is just they make a claim that it's improved over this quadratic scaling, but I think it's just a little funny the way that they make the claims. I'm still kind of thinking through it.
Okay. All right.
Super interesting.
Yeah.
If you can change the exponent, then that's not only
the payoff
shifting.
is huge, right? If it's actually
even if
replicable.
Even if it's a little bit. And we've got to figure out something that's not quadratic net long term. So
it's not going to work.
Yeah, exactly.
Yeah, super excited about the data efficient techniques for training.
Yeah. Me too.
Yeah, 100%. Zizi, what's your first topic?
So I've been watching video generation models and image generation models for a long time. I think, since the Sora announcement came out, I think it's over a year ago now. There has been continuous progress in the field in both commercial and also open source communities releasing new video generation models. But I think recently I really saw kind of like a Cambrian explosion of such models. And I want to run through a few either papers or announcements, maybe one short sentence for each, just to give you a sense of what's happening in the last few weeks. So the first one is Black Forest Lab. They have the Flux models. They have several versions of the models, and one of them is called Flux 1.1 Context. It's kind of similar to GPT-4o type of capability where you can do pretty fine-grained control of image editing. So that model used to be not open source. It was proprietary, but they're kind enough to open source it just recently.
Oh, wonderful.
And its quality is great.
And I know they have, a lot of their Flux models come in different sizes, and the smaller ones, there are multiple, are open source.
Right.
Or at least they're open use. The weights are available.
Yeah, exactly. I think most of their models are open source. They have some, higher tier models that are proprietary, but this context just went from proprietary into open source, which is very exciting. And then in a commercial APIs, we also View 3, and it's very very impressive with the audio plus video in sync. There's Hilo 2, there's Seedance Pro, and Clean version 2.0, and all of them I test them, and they're very 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 impressive compared to just a couple months ago.
What's the biggest shortcoming you still see with these models?
That's a great question. So although they are very impressive, however, when people are testing it to generate like sports videos, for example, tennis ball trajectories, playing tennis ball, you can still see, phenomena of the ball that's not complying with physics.
Right.
People have been using such models to generate, water diving of cats.
Yeah. Oh, yeah. And I saw the dog on the diving
all the
board.
funny videos. Yeah. Super fun to play with. And then the third one is MultiTalk. So that model is really interesting. It just came out, I think, last week. So it allows you to upload one image and 2 audio tracks. So that if that image has 2 person, then you can generate a video with 2 person talking. So like if you want to generate a podcast with two persons, now you have a tool to play with.
Oh, nice.
That sounds scary.
I know.
It's like totally lowers the barrier to entry to make videos of people.
Well, when they get to 3, we can save a bunch of time here.
I know. Yeah, we can totally automate this. This sounds great.
Here goes my weekend. And this one is open source too. And then the fourth one is called Blender Fusion. It's interesting because it's not only video. Sorry. So that one is actually 3D grounded visual editing. So you can use Blender, and it uses Blender as a verifier when generating.
Hold on, I don't understand that. So you would go into a little bit more color there.
Yeah. So I think this one, it generates visual contents, but not just using transformer model and using the model weights, but also has a tool calling. Using Blender to kind of as a verifier to bring the kind of grounding into the generation.
That makes a lot of sense.
Process.
Okay. Yeah.
I think that makes the takes us to the promising direction of grounding the generation to have more physics kind of reality.
Yeah.
And then the last one is called WonderPlay. And this is also a fun one. So it allows you to apply a 3D action on a virtual world. So like, for example, you can say, drop this rubber duck onto the water and see the effects. So then, it will generate you upload an image of a rubber duck, and then, it will see the effects.
And you'll see the ripples in the water and everything.
That's great.
Have you guys seen it's like, I think the Star Wars Stormtrooper video blog videos yet?
Not yet. What is that about?
So I think because they're wearing masks, they're wearing helmets, and you don't have to worry about lip syncing and things like that. They're really, really good. So they're essentially like video blogs from the first person perspective of stormtroopers, and they're holding like the camera out,
That's so funny.
And they're like, I'm on Hoth, and they're talking about how rough their day was. They're really, really well done. I mean, check it out.
That sounds great.
It's really, truly the first time I think I watched like a 5-minute AI video and was really impressed and like with the quality of the content and the humor. So loved it a whole bunch. Okay, so, all right, next topic. This is a bit of a big shift, but I want to talk about copyright law because, we've been talking for a long time about, when are we going to have legal rulings on all this data that's going in, copyright data that's going into training language models, and is that considered fair use? I mean, that's the term in America for sort of the standard for when you use copyright material in some way. And so to set the table, I did a little bit of research to make sure everything makes sense here. So fair use is the concept for copyright law, but it's judged on an individual basis, meaning there's not a broad standard. It's a doctrine. It's not a doctrine. It's a set of rules. And the courts look at 4 different things. They look at the purpose and character of the use. So was it transformative? You can't take somebody's copyright material and just regenerate it as is, and then say that's fair use. You have to have some sort of transformative use to it. You can't merely copy the original. Number 2, they look at the nature of the copyright use. Was it factual information, or was it more likely, or was a published work more likely to be fair use if it's in the creative domain? So, meaning if it's just factual information, it's harder to just demand a copyright on that. The amount and substantiality of the portion used. If somebody published a 5-second video and you use 4 seconds of it, it's kind of hard to argue that you are not just using all of it and there's this much transformation. And then lastly, this is pretty interesting, the effect on the market, right? Is this going to somehow negatively affect the market of that copyright holder? So there were 2 rulings recently. They came just days apart 2 weeks ago. So Anthropic was sued, and a federal judge also ruled actually mostly in favor of Anthropic. And they said that Anthropic, all of the copyright books that they purchased.
Yeah, they like literally purchased them, cut out the pages, scanned them. I've read this the other day. It's crazy.
You nailed it. They literally purchased just an enormous number of books, ripped out every page, scanned them, OCR scanned them for training. The judge ruled that was fair use, and because he felt it passed all 4 of those measures we just talked about, including transformative use. Interestingly, Anthropic also pirated a bunch of books. I think roughly like 7 million books. The judge says this ruling does not apply to those, and they will have to go to that case on their use will still be heard. But the really interesting thing about this is that there's a couple of quotes here from this judge that I want to read because I think it's really interesting. Get your head around where he's coming from. So when you're training an LLM with the copyrighted work, the question is fundamentally transformative. And the judge says, quote, the purpose and character of using copyrighted works to train large language models to generate new text was quintessentially transformative. Like any reader aspiring to be a writer, Anthropic's large language models trained upon works not to race ahead and replicate or supplant them, but to turn a hard corner and create something different. If this training process reasonably requires making copies within the LLM or otherwise, those copies were engaged in a transformative use. And that is basically his ruling. He essentially said Anthropic put in a bunch of safeguards on the generative side, on the inference side, to help to prevent it from just replicating content verbatim and reproducing copyright works. And so he essentially said, yeah, this is a transformative use. The authors argued that the work was essentially going to affect their ability from a market perspective, from a competitive perspective. And the judge, I've got to read this. This is just awesome. The judge essentially said, that is like arguing that school children learning to read your book is anti-competitive because they could grow up and write works of fiction and you'd have to compete with them. And he just basically dismissed that out of hand. Okay, so just the very next day, a different federal judge ruled on the same question, but this time with Meta. Interestingly, basically came out with the same ruling that he considered the copyright work fair use, but this is crazy. He all but said, I'm ruling for the defendant here because the plaintiff did a really bad job of arguing their case. And he all but begged them to come back and make a better case. Mm-hmm. And foundationally, he said that in the market competition front, that I think it was the Authors Guild that was in the lawsuit, they were saying that this is going to hurt their market of competitive capabilities. And the judge said, that's speculative. You have to come back with examples of that. Mm-hmm. And he went so far as to say that he essentially disliked this ruling, but that judges are forced to rule on the cases argued, and from the evidence, not what they think should have been argued.
Oh.
So it's very, very likely that the plaintiff here will come back and resubstantiate their case. But interestingly, the podcaster Ben Thompson, he has a great take on this, which is they're in a really tough place from a market competitive perspective, because you essentially have to show that purchases that would have been made of that author's work didn't happen. So you have to kind of prove a negative in a way. And that's a really, really high bar. So the first two examples of fair use case that we've gotten at the federal level essentially ruled on the side of the AI companies with a bunch of caveats. So I think I'm not sure we got a lot of clarity about where this is actually going to go long term.
Doesn't sound like it.
No, it really doesn't. It really doesn't. Okay, Michael, I'm going to throw it back to you.
All right. Man, that's crazy. I'm going to have to keep thinking about that.
Yeah.
So there's a new paper. I'll keep this brief. Luckily, it's pretty easy to summarize. There's a paper from CMU. I think this is at ICML, in addition to the one I talked about earlier. But it talks about this idea of state passing. And the idea is, well, I guess the problem they're trying to solve is that with recurrent neural networks, there is a strong performance drop-off whenever you increase input sequence lengths beyond what it was trained on.
Okay.
So if you train on a model on 4,000 token input sequence lengths, and then you try to do 128,000 sequence length inferences.
And this is for recurrent neural networks.
For recurrent neural networks, that's right.
Okay.
So all they did, this sounds so stupid simple, because it is, they just didn't reset the hidden state between mini batches during training.
Ooh.
So they're totally unrelated to each other. It's
that
like
makes no
jump
sense
in context. And their theory behind it is that there's a bunch that the state space is very underexplored if you just keep resetting it, but you improve the diversity of the state space that it explores during training by this.
Wow.
The crazier part is that it only takes like I think they said it was 0.01 to 0.02% of your training budget to do this as a post-training step to elicit this kind of behavior where that performance cliff doesn't happen anymore.
That is absolutely unintuitive to me because it feels to me like you would be maybe the analogy I would use is you translate a sentence from English to French, and then you start off your next translation with that French sentence already kind of in place a little bit. Like it's a little apples to oranges, but that just doesn't make intuitive sense to me.
I had the same thought whenever I think it was last episode, you were talking about the, using these verifiable domains, but you give it the wrong answer and it still improves reasoning model performance.
Right.
There's a bunch of weird, wacky stuff going on, but I mean, the performance results, undeniable. They were looking at Mamba, as you might expect.
Okay.
And there's,
that answers my question. I was like, why are they using a recurrent neural network in the first place?
State-space models, yeah.
State-space models, okay.
Yeah, that's what they're focused on. And they showed that, with this model, the performance drop-off happens at that, input sequence length, average input sequence length.
Okay.
And then the long tail, like if you scale it up to, I think they looked up to 256,000 token input sequences, drops down to like 75% drop off of performance. Now, with doing this post-training technique with literally just 500 steps for the same exact model, it settles out to about a 40% drop instead. And that settling is very gradual. I think it's figure 6 in the paper. If you want the one slide takeaway, you just watch it kind of just barely drop off versus that steep cliff from before.
Interesting.
And it's like you take out a line of code to do this. You don't add code.
That was the other thing I was going to say. I was wondering, was this a mistake? Did they forget? Did they actually forget to reset the context and notice?
That's a brilliant thought. Yeah, maybe.
To me, that's also an example, which I say this all the time, is like there are just basic, simple things right now with an AI that we haven't tried because there are so many of them to try, right? Like that's the reason I'm so optimistic that we're going to see so much progress in the near future, because little tiny simple things like that can have an impact.
Yeah, no doubt.
And it doesn't have to be to have a theoretical grounding or foundation.
Yeah.
It can be just smart engineering. It could be a
Wild
trick.
West.
Yeah.
Anything goes.
Yeah, exactly. Okay, I've got one more thing to bring up, which is, did you guys see that the Cloudflare announcement last week? That Cloudflare is going to, by default, now block AI companies from being able to access and index and search search without being paid, which is kind of interesting. One, Cloudflare has, I think they, back 20% of internet traffic or something like that. So that's not inconsequential. Two, I think this is a great move for Cloudflare from sort of a business perspective. It's another monetization stream. And three, it feels about like 5 years too late. I mean, hasn't the entire internet already been sucked into these models?
You'd think so, yeah.
Yeah, I don't
15 trillion tokens if you include the synthetics
exactly.
or whatever it is.
I think it's a great idea. Maybe just a little late to the table, so we'll see. I don't know. All right, guys, that was a great time. Thank you so much. And I'll see you next time.
Yeah, it's a lot of fun.
Good.
Thank you.
Thank you for listening to Hidden Layers. This series is hosted by Kung Fu AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at kungfu.ai.